Chemistry. This is the answers video for day 27. It's the second lesson in the solutions sequence of how to solve solution stoichiometry problems. There is no lectures video for this, nothing on PowerPoint, so we're going to do about half the problems on this answers video. All right, so you can see that on the first page what I've done is I've reproduced page 9 of your packet. And so everything that's on page 9 of your packet is there. In addition, up here in the header, I put down the big three conversions, which is 1 gram of water equals 1 milliliter of water. That's only for water. And then 1,000 milliliters of anything equals 1 liter of anything. And 1,000 grams of anything equals 1 kilogram. Okay, so this is due on Monday, October the 10th. So there's the cover sheet. We're going to move past that, and we'll move on to the first problem. Now, I have made the first problem, the most difficult problem is the first problem here. It's 1A. And many of these problems are A-B, as we talked about. I do the A problem, you do the B problem. I like this problem because it incorporates so many of the concepts that students can find difficult in stoichiometry and solution stoichiometry, okay? So these problems all come from either college level lectures or college level textbooks, so you're moving up pretty quickly here. Okay, so seawater has a density of 1.027 grams per milliliter and is comprised mainly of sodium chloride, that's table salt, and water. So you're going to assume that that's the only solute is the sodium chloride, NaCl. Okay, we'll write that down what that is. Okay, that's sodium chloride, NaCl. What is the molarity of a solution that is 3.5 mass percent sodium chloride? Okay, so a couple things that will challenge you at first and how to deal with them is density. You have a density there. The other thing is that what they're telling you is you have 3.5 mass percent sodium chloride. They don't tell you how much of the solution that you have. They just tell you that it's 3.5 mass percent. So we're going to talk about how to handle those two issues, okay? So the first thing we always do in a problem is we identify what the problem is asking for. And it's asking for molarity. Okay, and molarity is designated capital M. But anytime you're doing a problem with molarity, and there's just one small exception, and I'll talk about that later in this answers video, it's going to be moles of solute. So you come back here, you say, I don't know what molarity is. It's right there. It's moles of solute. In this case, it's the NaCl over liters of solution. The solution is the water and the NaCl mixed together. Okay, so let's go ahead and write that. That's what we're trying to find. So I'm going to go ahead and do this. Okay, that's what we're trying to get to is molarity. Moles of sodium chloride over liters of solution. All right, now, what are you starting with? Okay, so we'll talk about, let's go in order here. We practiced this in the last lesson. How do you deal with the density of 1.027 grams per milliliter? Well, you can write that as an equivalency, okay, and it would look like this. 1.027 grams of solution. Now, let's be sure. How do we know it's solution and not water or NaCl? What says seawater has a density? The seawater is the solution. It's the mixture of the NaCl plus the H2O. It's the two of them mixed together. That's what seawater is. And so that's going to be the solution, the SOLN, solution. Okay? Right there. So that's what seawater is. So it's 1.27 grams of solution equals 1 milliliter of solution. So now you can make two conversion factors out of that. Put this one over this one or this one over this one. So we've been doing that throughout the class. Okay, so the next thing is we identified what it's looking for. Now all it tells us is it's 3.5 mass percent sodium chloride. So that was a pre-assignment question in yesterday's assignment, the day 26 assignment. So how do we deal with that mass percent? We go ahead and we write it as we get to choose how much seawater we're going to test. It doesn't tell us that. It could be a milliliter, it could be 100 gallons, okay? It can be anything. So what we're going to do is, and we mentioned this yesterday, is we're going to choose 100 grams, okay? So I'm going to come way over here because we don't know how much space we're going to need. And we're going to choose, in the denominator is 100 grams of solution. That's the seawater. So if it's 3.57 mass percent and we have 100 grams of solution in the denominator, then on the top we're going to have 3.5 grams of NaCl. So if you do the mass percent calculation on this, 3.5 divided by 100 times 100%, you're going to get 3.5%. So we worked backwards from this to get this, and we did it by doing what we said we should do every time we have one of these problems. Choose 100 grams. And that will give you the same number of grams of your solute, in this case NaCl, as you had the number that was in the mass percent, that was the percent, okay? All right, so now we're ready to continue. And again, this is a two-story problem. It's both what we begin with, what we end with, have two levels to it. Okay, so first we start with the top. We have grams of NaCl, and we need to get to moles of NaCl. So right now, that should set off alarms, okay, and that's a molar mass conversion. By the way, with these solution stoichiometry problems, unlike the kind we did before with grams to moles, you don't know how many conversions it's going to be. You don't know how many boxes you're going to need yet, okay? So we're going to go ahead and just put them in as we need them, all right? So way down here, so I can get out of the way, I'm going to calculate the molar mass of NaCl. So Na, you have one of those times. Okay, so we bring in our periodic table, and sodium Na is 22.99 right there. And then chlorine, and we have one of those, 1 Cl. And what is that? It's 35.45 right there. Okay, so the molar mass. Okay, and I made a little mistake here. I actually added that wrong. It's 44. Okay, so 58.44 grams per mole. So that's what we're going to need to do the molar mass conversion. So we're going to add a box here. Okay, so the equivalency for this would be, there's the equivalency, which one goes on top and bottom here. So remember, we're not dealing with the bottom here, the 100 grams and the liters. We're only dealing with the top. So this is just a one-level problem on the top. So which one goes on top and bottom? We need grams to cancel out here and moles to appear on the top. So it's going to go like this. Okay, and grams cancel out with grams. And so we have moles of NaCl on the top. That's what we want in our answer. So for the top, we're done with the top. That's the unit we need in the final answer. Now we need to get from grams of solution over to liters of solution. And so now we're going to start putting boxes over here where we have space. Okay, so grams to liters. Grams is a measure of mass, liters is a measure of volume. Okay, so normally there's no relationship between mass, grams, and volume in liters. But we do have one up here because it was given to us, and that's what density is. It's a relationship between grams of the solution and not liters, but milliliters of solution, but that's okay. That'll get us towards what we're trying to do, get our final answer. So now we have a second equivalency that we've already developed out of the density. So we're going to put a box here, and we're trying to get from grams to liters, so we need to get rid of grams. So which one of these two do we put on top here so that grams cancels out? The answer is the 1.027 grams of solution. And the other goes on the bottom, the 1 milliliter. Okay, so grams of solution cancels with grams of solution, and we have milliliters of solution on the bottom. We need to get to liters, so we can use one of our big three conversions up here, and that's the one that goes from milliliters to liters. It's not water, so we don't use this one. We don't need this one. It's just 1,000 milliliters of anything equals 1 liter of that same substance. So we're going to go ahead and draw another box here. We need milliliters to cancel out and liters to appear on the bottom. So we're going to put the 1,000 milliliters of solution on the top and the 1 liter of solution on the bottom. So milliliters of solution cancels there and there. And the last man standing on the bottom is liters of solution. So we have all the units set up correctly. So the next step is just to do the math. Okay, so it's going to be 3.5 times everything on the top, times 1, times 1.027, times 1,000, and then you divide by everything on the bottom. Divided by 100, divided by 58.44, divided by 1, and when you do that, you get this 0.62 or 615. Either way, I'm not worried about the significant figures, and that is your final answer for this. So what I want you to do is do the B problem, which is identical to this, except the numbers have been changed. I do give you the answer there. I'm pretty sure that's the correct answer. So go ahead and do that one on your own.